Welcome to part 2 of our 4-part series for those who are in love with the mechanical world, or gearhearts as I've come to call them. In part 1 of our series, we designed the basic shape of our enclosure around a few existing gears using some basic features. In this portion of the series, we will start adding some patterned detail to this design, and we'll use some additional essential features to expose its inner workings. We're going to create a gear tooth pattern around the perimeter of this heart using the curve-driven pattern feature. The pattern will add some aesthetic detail to the part, but also function as an alignment aid for the two enclosure halves. Let's start by creating a sketch for our curve. Let's sketch on the front face of the heart and simply use the Convert Entities sketch tool to copy its outer edge. Clicking on the face of the heart converts its entire perimeter, rather than having to select the individual edges. Now let's create our gear tooth extrusion that we want to pattern. I'm making sure the tooth is perpendicular to the curve. I've already taken some dimensions off of the existing gear teeth to make sure I dimension this element to about the same size. Let's extrude this tooth on the mid-plane, and I know the gears are 3/32 of an inch thick, so I can type in that fraction and let SOLIDWORKS do the math for me. And let's make sure this tooth only merges to the base part by using the Feature Scope option. We're ready to create our pattern. Let's select our curve sketch and come up to the drop down under Linear Pattern to find the Curve-Driven Pattern feature. In the Curve-Driven Pattern Property Manager, you have several control options. You can control the number of instances you'd like to make of the original, or seed, feature. In this case, we will create 60 equally spaced teeth. Let's select the Offset Curve option, which maintains the normal distance from the origin of the selected curve to the seed feature for each instance. We also have control over the alignment method, where you can choose to keep the instances tangent to the curve, or you can keep each instance in the same orientation as the seed feature. In this case, we will keep the instances tangent to the curve. Another interesting option that we'd like to utilize in this design is the option to skip instances. We don't need teeth where the small gears are going to protrude from the edge of the enclosure, so we can choose to skip those instances. Let's do this on both sides of the heart, as we will include 2 small gears in the final assembly. Note that you can only skip instances when you're patterning features. The Skip Instances option is disabled when patterning bodies. Now let's create the internal pockets for our gears. We will sketch on the face of the heart base and create some circles that are offset 0.010 of an inch from the outer edges of the gears to design in some clearance. And we will mirror the smaller circle across the origin to create the pocket for the other small gear. Using the Extruded Cut tool, we can cut this pocket into both halves of the enclosure in one operation. We will do an extruded cut in one direction, half the thickness of the gears, by typing in the equation 3/32 divided by 2. And we can do an extruded cut in a second direction using the same dimension plus an additional 0.010 of an inch to design in some clearance. As mentioned earlier, the tooth pattern will also act as an alignment aid for assembling the enclosure halves. We can cut away the inside of the teeth using the curve sketch we already created for the pattern. Now we will design the center rods for our gears to be part of the enclosure base, starting with some simple offset sketches. And let's leave about 5/1000 of an inch for assembly clearance. Again, we will mirror the rod for the small gear to the other side of the heart. These rods that the gears run on will also allow us to assemble this pendant using a cold assembly method, either rivets or perhaps a quick puck weld. So let's leave a little bit of excess metal sticking out through the front of the heart. In the Extruded Boss tool, you can choose to extrude to an offset amount from a surface. In this case, we'll make sure our rods stick out 0.05 inches from the front face of the heart. Let's finish up this part of the series by creating some cuts in the front of the heart to expose the gear mechanism. We'll start by using some converted and offset entities. And we'll design in some supports for our gear rods. We'll also set some dimensions and relations on this sketch relative to the internal components to make sure our sketch is fully constrained. Rather than use the Trim Entities tool to create a single closed loop sketch, I'm going to exit the sketch as is and walk through an interesting option with you in the Extrude feature. We're going to use the sketch to do an extruded cut through the enclosure cover, and we're going to utilize this option called Selected Contours, which allows us to select any closed region in our sketch to use as a cutting tool. So let's just select the two large areas we want to cut away to expose the gears, as well as the clearance holes for the gear rods. And lastly, let's soften up the corners with some 20/1000 of an inch fillets. That wraps up part 2 of this 4-part series. Stay tuned for the third portion of our series as we turn this geared heart into a unique reversible design, and we'll walk through adding some custom text features to the back of the part.